Sun, an 8th grader at Highland Park Middle School. I created a cellular automaton simulation of cancer growth using Python. This program specifically modeled hypertumors, which are mutated tumors growing within tumors. I changed the size of the grid the tumor was in to represent different animal sizes.
My program started with a grid, and each square of the grid contains 2 healthy cells. One was randomly chosen to mutate into a cancer cell. From there, cells divided, moved, and died, with each cancer cell having a 0.1 chance of mutating into a hypertumor cell. Cancer cells split at a faster rate than healthy cells. The cells went through many generations of this, and here is an example run in a 60 by 60 grid. Here is the full grid of healthy cells at the beginning of the program. As you can see, the cancer cells slowly take over the healthy cells, and then the hypertumor cells in turn take over the cancer cells. At the end of the simulation, there are only hypertumor cells remaining. But in larger grids like 800 by 800, the hypertumor cells took over the cancer cells before they took over the healthy cells. At the end of the simulation, healthy and hypertumor cells were alive, but none of the original cancer cells were.
In summary, I found that if an animal with cancer is large enough, a hypertumor will take over the tumor and then stop growing. This cures the animal of the cancer. With my results, I propose a new method of treating cancer. We could introduce a fast-growing substance into a tumor that is unable to grow into healthy regions. A recent Duke University study tested the effects of a modified poliovirus to combat cancer. It was successful, showing that this method does work. With this, we could cure the world of cancer forever.